So good day, everyone. In the previous video, we have discussed about what proposition or statements are and what are some examples of propositions. Okay, so for today's video, we are going to talk about compound propositions. But before we continue, let me ask you first. So when you communicate with others or when you talk to others, so do you only use simple statements? So often we use more complicated na statements or combine simple na statements using or and, etc. So that is similar for mathematical statements. We also combine simpler statements into more complicated ones using words or phrases like and, or, if then, etc. Okay, so these words or phrases like and, or, if then are called as logical operators or logical connectives. Okay, so in this topic, we will talk about compound propositions wherein we are forming new propositions from existing na propositions. Okay, great. So let us continue. So we have some examples of compound propositions. We have the negation, the conjunction, disjunction, exclusive or. So this negation is formed from one single existing proposition, and some new propositions are formed from at least two na propositions. So these are the conjunction, disjunction, and exclusive or. So for this video, we are going to focus on negation. Okay, so what are negation? So suppose we have a proposition or a statement P. So when we refer to the negation of P, we mean not P, or it is not the case that P, and it is denoted by this operator, not P. Okay, so from the word negation, we refer to the opposite na value. Okay, suppose we have a proposition P. We know that a statement or a proposition has a value of either true or false, right? So if what will be the negation of this value? So if your statement P is true, its negation will be false. Okay, so if your statement P is false, its negation or not P will be true. Okay, so you are just getting the opposite na truth na values, right? So let's have an example. Suppose we have this statement P, the integer 2 is even. So what will be its negation? All right, so the not P could be expressed this way. It is not the case that the integer 2 is even. But it is simpler to express not P as the integer 2 is not even. And is there a better way of expressing this one? Yes, so it would be more understandable if we just write not P as the integer 2 is odd. Okay. Okay, so let's have some more examples. Okay, so state the negation of each of the following statements. 5 is an even integer and 0 is not an odd integer. So our task is to write the statements A and B in symbolic form and determine the truth value of the statement. Okay, so 5 is an even integer. 5 is an even integer. So we will express it. So let P be 5 is an even integer. So what will be its negation? So we can write it as it is not the case that 5 is an even integer. Okay, but it would be better to write it as the integer 5 is not an even integer. And the simplest way to write it is the integer 5 is odd. So now, one of our tasks is also to determine its truth value. Is this True or false? Yes, the integer 5 is odd, which is true. All right. So now let's proceed to another example. 0 is not an odd integer. So we let P be this statement. Okay, so what will be its negation? It is not the case that 0 is not an odd integer. So we can write it correctly as 0 is an even integer. So is this true or false? Yes, it is true. Okay,